Hello, periods 4 and period 6. We're going to be going over our lesson 9.4a guided practice for March 23rd, 2020. And lesson 9.4a, we're going to work on using square roots to solve quadratic equations. For guided practice 1 through 8, the problems that we are going to do together, we're going to solve each equation and using a calculator only on numbers 7 and 8. We will need a calculator that can take square roots, so even a basic four-function calculator typically will be useful for working out your square root problems. Of course, any other higher level calculator will have that capability as well. So let's take a look now at guided practice 1. On guided practice 1, we're asked to solve c squared minus 25 is equal to 0. Our goal will be to isolate the square, that's c squared in this case, and then take the square root to get down to the value of the variable for the solution to this equation. First, we add 25 to both sides of the equation. That will give us c squared is equal to 25. Now, to undo this square here, what we're going to need to do is take the square root, because squares and square roots are opposite operations. But of course, we'll need to take the square root of both sides of the equation to keep it valid and true. When we take the square root of both sides, we're going to arrive at both a positive and a negative answer. When you take the square root, there are always two roots, one positive and one negative, and we'll need to report both of them. That's why the plus minus sign is here, to indicate that we're going to find both roots. When we take the square root of 25, we do know that's 5, and so we'll have c have a value of both positive and negative 5 for our final answer. Guided practice 2. Well, this will have a little bit different kind of solution, so let's see what happens when we solve for w here. First, we're going to undo the plus 12 by subtracting 12 on both sides. That's a good first step because our goal is to get it down to w, and to get it down to w, we'll need to remove all of the numbers that are sticking to that w squared, and then of course undo the square at the end. So subtracting 12 on both sides gives us 5w squared equals negative 12. Then we're going to divide both sides by 5 so that the 5's cancel out here, and we're down to w squared equals negative 12 over 5. And then our next step will be to undo the square. So we're going to take the square root of both sides, which would give us, of course, a positive and a negative root. But in this case, we can't find a value. There is no real number solution to the square root of a negative number. So since there is no real number answer to the square root of a negative number, there is no solution to this equation. That is, there's no real number solution. When we proceed into Algebra 2, we're going to learn a little bit about what kinds of values that we get to the answer to the square root of a negative number. But here in Algebra 1, if we're trying to take the square root of a number that's negative inside that radical, we'll simply say there is no solution. So that's our answer. There it is, all boxed up, no solution. And that's the work up here that we need to provide to realize that we have no solution. Guided practice 3. Guided practice 3, again, our goal is to find the value of x, so we need to isolate x squared, and then we need to take the square root once we have it down to x squared to find the value of our variable. So first we're going to subtract 11 on both sides. That will give us 2x squared equals 0. Then we're going to divide both sides by 2, and that's going to give us x squared is equal to 0 divided by 2. Remember, 0 on the top, okay, 0 on the bottom, no way. So when we take 0 and divide it by 2, we do arrive at the value 0. If that 0 were in the denominator, of course, then that will be an undefined answer. But we've got 0 in the numerator, so our answer, 0 divided by 2, is 0. We're going to take the square root of both sides, and of course we're looking for both a positive and a negative root here. The square root of x squared is x, and when we take the square root of 0 and we ask, well, what does it mean when we have both positive and negative 0, we say, well, there is no sign on 0. So we simply report our answer as x equals 0. Next problem. 25x squared equals 16, so our first job will be to divide both sides by 25. Remember, we want to get that x squared by itself before we take the square root of both sides. So that's why we're dividing by 25 on both sides first. That will give us x squared is equal to 16 over 25. And then we say, well, we need to undo this square, so we're going to take the square root of both sides, to give us our x, and then we have over here both a positive and a negative square root of 16 over 25. And notice that both 16 and 25 are perfect squares. So we're going to think about that as the square root of 16 separately from the square root of 25, and simply take the square root of 16 and get 4, take the square root of 25 and get 5. And so our answer then will be x is equal to positive or negative 4/5. Don't forget to attach that plus minus because there are two roots to this quadratic equation. So there's two solutions, both positive and negative 4/5. Got to practice 5. On this one, it'll be very similar to the last problem that we worked. We're going to divide by 9 first to get it down to the m squared. So that all we have to do once we get it down to m squared is equal to 100 over 9 is take the square root of both sides. We're going to get both a positive and a negative root again. And we're going to do the same kind of thinking that we did in guided practice 4. We're going to think, what is the square root of 100? And that gives us 10. What is the square root of 9? That gives us 3. So we're not going to actually divide this out first because there are both perfect squares. It's easiest to solve this if you simply take the square root of those perfect squares and report them as separate numerators and denominators. And then our plus minus comes right along, and we have two values that solve this equation. M is equal to both positive and negative 10/3. That is a fraction. It is in fully reduced form, so it's fine to leave it in that form. You don't have to divide it out, but if you did and you got positive and negative 3 1/3, that also would be a correct answer. Here comes another problem where we're going to find there is no solution. On this one, 49b squared plus 64 equals 0. We're going to start by subtracting 64 on both sides. That will give us 49b squared equals negative 64. Then we're going to divide both sides by 49. And we're going to get b squared equals negative 64 over 49. We're going to take the square root of both of those sides to get this down to b. And once again, we see there's a negative number in our radical, and we can't take the square root of a negative number and get a real number. So even though these are nice perfect squares, 64 and 49, and we're tempted to say that the answer to this would be 8 over 7, since the square root of 64 is 8, the square root of 49 is 7, we actually can't do that because there's no solution given the fact that we have a negative inside of our radical. No real number will answer this question. So again, B is no solution. We do need to show all that work before we state no solution. Guided practice 7 and 8, we're going to use our calculators at the end of working out this problem to get some values, since we will not have perfect squares in our radical this time. So we're going to start the way we have on all our other problems. We'll start by isolating x squared. In this case, we're going to subtract 4 on both sides. And then we arrive at x squared is equal to 10. Then we're going to take the square root of both sides, and that would give us x is equal to positive or negative root 10, and we need to figure out what that root 10 is. So this is where you're going to use your calculator to find the square root. You're going to end up rounding the value you see on your calculator to the nearest hundredth. You should see something like this on your calculator, a bunch of digits past 3 point, and on my calculator it showed 0.1622776, and it went on. At some point on your calculator, these numbers will stop. It doesn't mean that there aren't any other further digits. It just means that's how far it's going to display it. That's why these 3 dots are here. It goes on. But you're not going to write this answer down for your final answer. Go ahead and write down what you see on your calculator and then round off that number to the nearest hundredth. That means you go to the second place past the decimal, which is 6. You look at the number to the right, which is 2, and that makes you round the 6 down. When you round down, if you recall, that keeps the number the same. So my x is approximately, notice the wavy equal signs, we're approximately equal to both positive and negative 3.16. So that's rounding to the nearest hundredth. You actually don't have to have this part on your paper, but you're free to write that down so we can see how the rounding works. Guided practice 8, our last guided practice problem. Again, we're going to round our solution to the nearest hundredth because it will not come out a perfect square. This one will be a little bit trickier on how we work it out. First, we're going to add 1 to both sides. That'll give us 3k squared is equal to 1. Then we divide both sides by 3, and that'll give us k squared is equal to 1/3. Now it's time to take the square root of both sides, and that will give us k is equal to positive or negative root 1 over 3. So how do we put that into our calculator since this isn't a perfect square situation? Well, what we're going to do, first we're going to key into our calculator 1 divided by 3 because that's what 1 over 3 means. And on your calculator, you'll see on your display 0.3333, and it's just going to keep going because it's a repeating decimal. Then you're going to take the square root of that number you see on your display that is a non-terminating and repeating decimal. And when you take the square root of this repeating 0.3, you're going to get this value on your calculator. Again, you're going to round to the nearest hundredth, so go to that second place past the decimal point, the first 7 here. Take the second 7 and use it to round that first 7 in the hundredths place. You're going to round that up, since 7 will ask you to round this 7 up. So that'll change to 8. And here is our value, and really technically should say k is approximately equal to positive or negative 0.58, but I'm showing it this way because most books will actually show that as an equal sign, not a wavy equal sign, because it's just standard practice to round off to the nearest hundredth when you're finding the square roots of our non-perfect squares. Okay, so that's it for our guided practice for our lesson today, 9.4A. So now it's time to make sure you have all this guided practice recorded on your paper and to start working on the homework. And remember, after you're done with the homework, on the next day we move on to the samples, and the guided practice, homework problems, and samples all need to be turned in under lesson 9.4A. All right, have a good rest of your day.